Field meetup. It's a slightly smaller crowd, but that's all right. It's great to have all of you guys here. Tonight we have a really cool presentation from Anna at Apis Cor. She's going to be telling us about how 3D printing can change the way we build our houses. All right,
yeah.
Take it away.
Yeah, thank you very much. My name is Anna. I'm CEO of Apis Cor. We're the company that developed unique 3D printers to 3D print houses. It's basically like how to build houses robotically. I believe you all know, or at least heard of 3D print houses. It's like a very innovative stuff that's rapidly going to the reality today. And so we are the company that developed the technology with proprietary technology, and we 3D print houses today. So I would be happy to tell more about what we do and what's our projects and progress so far. And yeah, thank you very much for having me. It's a huge pleasure to share about our company and what we do. So I would like to start with the video that we made like several months ago, basically introducing the technology and what's the difference. So it's like a very good introductory for like what is this and why we need to even think and talk about this. So it's also going to be me there. So it's going to be two of me right now. So yeah.
One of the things we've learned at Alchemist is there is great power if you can build a product that changes how an entrenched industry operates. These products are powerful because the initial product itself can become worth billions, but all the ancillary products and services that are needed with that change can be even 10x that. We've seen this with the iPhone, which has changed how we think about phones, or Tesla, which has fundamentally changed what we think of as a car. We think this next company will do the same with construction. They are 3D printing homes, and they have the Guinness record for the world's largest building ever 3D printed. It's compelling not just because of the 3D printer that they've built, but also they have a proprietary material which is needed for the printer to operate. We've seen the power of additive manufacturing in industry. We think there is an equally, if not more compelling opportunity in residential and commercial construction. So without further ado, please welcome Anna from Apis Cor.
Me.
Hi, I'm Anna, and we build robots to 3D print houses. Yes, you heard me right. I'm talking about 3D printing the full-size houses robotically. It sounds like a science fiction, but this is the reality happening today. Have a look at this large two-story building. It was 3D printed. The concrete-like material was distributed by a robot, layer by layer, creating the desired shape of the building. Even more amazing, it was 3D printed by our one single 3D printer, because unique design of our machine offers compact dimensions and true mobility, allowing to print houses of any sizes. It's also self-driving and can be easily transported by regular pickup truck, and it's ready to start printed houses right away upon delivery. Building a house becomes a matter of pressing a button. But it wasn't necessary some 100 years ago, right? It was not too many people on Earth, so the housing demand could match with the stone, mud, and mostly manual labor. But today, it's a whole nother story. Considering the growth of population, by 2030, we would need to build as many houses as for the previous 2,000 years. Although the construction materials evolved, basically changed their shape and size, the manual assembly is yet a must. It takes a lot of time. Speed and quality heavily depends on skilled labor, which is limited today or even unavailable in some countries. So the task of providing affordable houses is no longer possible with such approach. Henry Ford solved a similar problem with the car industry by introducing automation, and thus tremendously expanding the industry. This is just the same what we are doing for construction industry. We are targeting the low-rising residential construction market, which counts almost 1 million units built annually in the United States alone, and 15 times as much for the rest of the world. By utilizing our technology, construction companies can build 9 times faster more cost effectively, and with exceptional quality, something they have been always dreaming about. And we also deliver our proprietary 3D printed material on demand, ensuring the consistent results for our customers. This enabled one of them to save up to $1.2 million on his upcoming project of 60 houses. They just add water and get their Insta houses. This is the future of construction. As of today, more than 15 companies have trusted our vision and placed the deposits for their printers. They're ready to start to print hundreds of houses, creating a great impact on the planet and maybe another one. We are Apis Cor. We are forging the future where robots 3D print houses.
Thank you, Anna, for this presentation. Yeah, I believe it really helped you to understand what the point of 3D printing technology is. So basically, 3D printing technology for construction today, it's the tool how to build houses faster, also cheaper because you significantly reduce the labor involved in the process. And so you also reduce the cost that needed to finish the house because machines can do the work with a repeatable quality, so it's like way less errors and that you actually need to fix and also spend money on it. But at the same time, the automation and 3D printing technology, it's not something that takes our jobs, because today we have a huge gap between how much we actually build every day and how much we actually have to build. So this is the huge gap, like a shortage of the houses. And with the robots and automation, it's not something like we take the job of people who build in the houses. It's how to fill this gap with the houses and build more houses. So it's also about the availability and affordability as well. So as we know, any automation, any automated process, it's how to do something faster, better, and how to increase productivity. So this is what the 3D printing technology is about. And I would say robotics 3D printing technology for construction. So we're still kind of trying to figure out how to name it shorter. It's still keep the sense so people would understand this. But I would say it's robotics 3D printing construction technology. Let's get everything in this name and then figure out what's better. So, but today I also would like to tell about our company and what we do. So our name is Apis Cor. So Apis from Latin, it's actually bee. And as you know, bees, they're the ones who use extrusion process to build their houses. So this is the inspiration for our company. And so as I said in the video, we 3D printed the huge building in Dubai. It's officially the world's Guinness record. It's officially the biggest building 3D printed ever on Earth. And it actually was possible because we have the completely different technology that today offered in the industry, in the market. So we have the portable solution that actually you can easily move around the construction site. And this is how you can build basically houses and buildings of unlimited square footage. So this building in Dubai, for example, it was around 11 or even 12 locations for the printer. And we just moved the printer around this. And this is how we managed to print this a huge building. And this is how the building looks inside, because for the 3D print walls, you can apply any type of finishing that you typically apply for the concrete masonry unit walls or concrete houses, or even stucco, this type of finishing, you can apply this. And so the question is why we need to use 3D printing technology for construction? Why this is the key to change how we have been building houses. So basically the additive technology is so there is a subtractive process how to do something, when you mill, for example, or you cut out the material that you don't need, and this is how you get the shape that you want to have. But additive manufacturing is like how to build something like the object without like cutting everything out. You basically add as much material as you need and you create the shape that you need. So this is the additive process. And this process significantly reduces the amount of waste, and also you don't need to do all of the post-finishing. So this is actually just a random picture from internet, but that was like concrete 3D printed. So here you can see that the shape is pretty complex, but it was just built with the exact amount of material without like having any waste for the post-finish. And so this is also one of our walls that we 3D printed. So, and here you can see the quality, and it's actually not the best quality that we can print, but even with this quality, you can see that you basically can just paint the wall if you want. You're still gonna have some strips, but that's fine. Some people like it, somebody like, oh no, we will apply some stucco. But even it's even like cheaper to apply stucco for this type of wall if you compare to the concrete masonry unit wall. If you're lucky enough to have a very good workers, they can build a very nice looking CMU wall. But sometimes it's not the case, so the quality is really like different from project to project. With the 3D printing technology, your quality is constant and consistent all the time because you build houses with the machinery accuracy. So this is another advantage of applying the robotics and machinery construction 3D printing. And here you basically can see our robot. And you can see that the robot kind of large, but if you see the person there, it's actually Nick, our founder and inventor of the machine. Compared to human size object, it's not very, very, very huge, right? And the very like significant advantage that our technology have that you can see here that it's like a continuous tracks, so basically like the caterpillar wheels, and using it like a joystick or like a tablet, printer moves. You don't need to use like a cranes or 10 people just to move and deploy the robot. It's basically like almost autonomous. And the printer also lifts up, so up to 3 meters, it's like 9 feet. And so then you also can put the printer on there. Very simple made metal frame, and this is how you can increase the printing height. So this is another huge advantage of the mobile and portable robot that we developed and used to 3D print houses. And this is the picture of our recent project that we're going to release soon, so stay tuned for more announcements. And I assume that the question that you probably have right now in your head, like, oh, is it safe and sound? How it's reinforced? It looks nice, but if it's really like strong. So yes, the house that we print and the material that we develop, that allows us to print wall structure that's structurally the same as concrete masonry unit walls, and it's actually stronger, almost like a 30% stronger. And so this is how we basically can ensure that the structure of the 3D print house, the walls, they're structurally safe and sound and also comply with the building codes. Here you can see like a very simple picture how we actually reinforce it. So the walls, they're not just printed. The cavities inside, they can be reinforced the same way as it requires for concrete masonry unit walls. Concrete masonry unit walls, it's like the gray box, they commonly used in the United States and in Florida, and it's very well documented. Very well known how to reinforce them. So we basically do the same. Material even stronger than CMU, and walls also reinforced the same way. So this is the vertical reinforcement in the wall. It's like the top view. And here, and here, and here, you basically can see the rebars and ladder mesh that also required for concrete masonry unit wall, and we just do completely the same. So the difference is like that our walls are built robotically instead of put together manually. And this is also the example how we reinforce the building in Dubai. So building in Dubai was a little bit different. So it was not the CMU style. It was just the structural columns. They were like over-reinforced because we just put some safety factor to this. But basically it would be reinforced columns, you can see it here, and self-bearing walls between the columns. So this is how we achieved the structural integrity of that house. It was quite a significant project for us. And I would say for the entire industry because nobody did it so far. And when I'm saying that, we do basically the same as concrete masonry unit walls and how we comply with the building codes. Basically that means that everything, structurally wise, is done the same as CMU walls. So here you can see the bond beam, for example, here. Again, it's done the same as for the CMU wall. And here you can see the joists, even the schedules for the opening, the doors and windows. And here, for example, this is the precast U-lintel that also used in masonry construction. So we kind of like combined what already approved and already used and like fine, and how we can like incorporate it in our innovative approach. And here you also can see how the roof is starting to be built. This is the project during the final stage of the construction. A lot of wood and everything. But you can see that walls are printed. And actually when we say like a 3D printed houses, it's important to understand that only walls are 3D printed. And even having the 3D printed walls printed, it's already the huge step forward how we can increase the productivity. Because basically the wall structure, the shell of a house, is one of the biggest part of the construction. Of course, it depends on the quality of people that work to build a structure, but in general, if you don't have walls, you don't have a building, right? You don't have a house. And if we can significantly increase the productivity for this process, it's already like a significant advancement. For example, when you use the electrical drill, you don't say like, oh, it's only do the nuts on the screws, right? Of course, you can use the manual screwdriver, and you probably after 100 nuts, you will be like done with this forever, right? So we use the electrical screwdriver because this type of power tools help us to do the hard work faster, easier, and increase productivity. Here the wall structure, so you also can see the quality of the wall. Sometimes we just paint them. And this is how the roof also can be done. So you see it's pretty standard roof. So we don't print roof, we again just apply what already used today. And but for the forward-looking for the technology, we have a few solutions that we are right now developing. How we also can, for example, print the roofs or slabs or like ceilings. It's something that we're working on right now. And how we also can do the value engineering. So for example, we can install the electrical, mechanical, plumbing as we print. So we basically speed up the entire construction process. So this is the good thing about the 3D printing technology, because this flexibility in the design and wall structure allows us to like, oh, how we can do insulation, how we can do this, how we can do this. We can a little bit like change the design and facilitate more structures just built in the walls. So it's, of course, it's like a completely different chapter for a lot of technical details, but technology allows to open a lot of opportunities how to improve not only the process to build the walls, but also the other structural parts of the house. And I probably will just wrap up my presentation with a really forward-looking statement. So this is something that we also have been working so far. So basically, how this technology can also be applied not only on Earth, but some days on Moon and Mars. Because realistically, robots are going to be the first and they're already the first who are already there, right, to build something. So the additive manufacturing and robotics construction is looks like the best solution to send them there and start building something there. So just to inspire you and provide you what the horizon of the technology, not only on Earth, but also something that we strongly believe will be a main part of the colonization of the other planets. That's, we all know someday it's going to happen. And this is actually our work for NASA that we did 2 years ago, and it was the design of the habitat on Mars and also 3D printed some mockups just to demonstrate that we can do it in a full autonomous way. Of course, it's like a very long shot, but it's better to start earlier, right? And so I probably stop here. And I would say that this technology is not something that you can learn for like a 10 minutes presentation or like a two hours presentation. So sometimes it really requires like days. So this is why we created the Ecoscore University. It's basically online courses and in-house workshops where you can actually come and see how everything works. So here, for example, the picture from one of our workshops. We do the live printing, where you can touch the material, see how it's completely different. And actually, the 3D print material it's not the concrete. It's the cement mortar, but it's still much stronger than the regular concrete. It's, again, like a completely whole another story about the material side. So if you want to really learn more about the technology and commit some time for this, so that would be, we would be happy to see you at Apis Cor University. Thank you. Yeah, of course. Well, go for it right there.
Hi. So I guess I want to know about the rebar reinforcement, right? So of course rebar is a giant rod, right? And so I'm thinking of it sticking up from the base. And so as you're bringing the base, the nozzle has to go through. So how are you going around the rebar?
I gotcha.
Yeah.
So, probably you can see here, this is our extruder. So basically this compact extruder allows us to bypass the rebar. Yes, because according to building codes, the vertical dowels can be up to, coming out from the concrete slab, up to 1 feet, even less. So we can easily bypass this this height. And also, that's another way how you can do this. You can do epoxy installation of the rebar. So basically, you 3D print 1 feet, and up to first you drill the concrete, and then you print the walls. And then once you're 1 feet tall, you install the first piece of rebar. And once you complete the entire wall, you install the remaining part of the rebar. And that's
then you can fill it back in.
Yes, and then you fill everything. Again, it's something that we didn't invent this. It has been existed in the building codes for many years. We just really match and comply with everything that's already required.
Okay. Thank you.
Yep, absolutely.
Good evening, Anna. Thank you for the presentation. It was very insightful. Thank you. My question is, so when you have a building of 1,000 square meters, the idea of 3D printing is to keep track of everything on the site of an actual building. How do you keep track of registering the printer every time? Do you have wireless beacons or coordination system or registration somehow when you move the printer to keep track of where it needs to print?
No, you don't need to do this. So if you're familiar with the CNC milling, for example, or CNC machining, you can always move your 3D model or your file, and then you kind of put the new 0 for the machine and put the another point for the machine, and then the software automatically adjusts the like the model. And machine like it can know all the time how to keep printing correctly if you update the new position correctly. So we don't use GPS or something like this. It can be done in a much easier way. So it's basically a software solution.
So you have to manually, so every time you move the machine, you have to manually locate where you are at that point.
No, you don't need to manually locate with a printer. You just need to say printer, like where the last point and where the any other regular point on the new part of the print of the building. Yeah. So
triangulate where you are at that point.
Yeah, it's like again, this process is something that also existed before, so it's not a big deal. So if you're familiar with CNC, you would probably understand me. But you just need to create the new 2 points and kind of link the first point to the previous one, and then the software do the hard work.
Okay. Thank you.
Where do you run your university at?
So the online courses, it's online. So we called it Apis Cor University because it's like the separate environment where you can find online courses and workshops. So workshops, it's something that's done on-site in our headquarters in Melbourne, so basically located here. So workshops is going to be in February, and the registration is open right now. So you actually can go to our website and find the information there. Yes?
What would you say are some of the biggest challenges when 3D printing a house? Like, why aren't we seeing a lot of houses being 3D printed right now?
Because the technology is pretty, realistically, it's not easy technology. Because it's like the intersection between the software, material science, robotics, building codes, building performance technologies, construction technologies, and it's also the real world, right? So when you deal with this, it really takes a lot of time, and it's the question of the funding and everything. But I would say that basically it's just because the technology is so innovative, and in the beginning people were so excited just to see the 3D printed sausages. And it was really hard to define what's really needed to be done to scale this technology up. Because, do the prototype, it's so easy, but how to scale up and do the mass production, it's a completely different story. So this is why we see a lot of houses here and there, but it's not something that can be done really quickly everywhere. Because the technology is scaling up just right now. If you just, for example, 2-3 years ago, people were like, what, 3D houses? What is this? Now it's not going to happen, But today it's like, yeah, I know about what you're talking about. And like the building officials, they're like, yeah, we heard of this. And having your information at Apis Cor University, now we understand what it is. Because education is also a huge part of this. Big changes, they all the time take a lot of time. It's not something that can happen overnight. So I would say that right now technology just started to scale it up. Because right now it's more clear what really has to be done. And even for us, it took several years for research and development, right? To figure out what's really needed to be done and how it should look like, right? So we did a lot of tests, because you don't want to offer something raw, it's something that's not going to work, right? So it's just the hard technologies, I would say, yeah. Who's first?
How would you repair these houses? Because the walls are a lot different than, everything that we've built so far, but it's easy enough to go in and repair it. So how would you do it with this?
What do you mean repairing?
Like if I were to crash a car into the house, how would you repair it?
How would you repair it if it was CMU wall?
Well, it's made out of wood or brick and stuff like that, so how would you do something that has been printed by a 3D printer with a different material than regular concrete? Because you would want to use the same material to have the same type of structural integrity that the rest of the building has. So if it's 3D printed by a specific machine that's, it'd be very expensive to bring it out there and print it right on site, so how would you go about repairing something with the same material? Would you use something else?
Yes, it's a great question, by the way. So this is why we do the walls that's structurally the same as CMU. I probably said a lot of time for CMU, but it's like what we do. So if you do something that already existed before and existing right now, you basically can do the same for the 3D printed walls. So if the car crashed into the wall, you basically have like a hole in the building, right? So what you would do with a CMU wall, you basically like smooth all of the edges, right, and then install the bricks or like the same CMU blocks. With the 3D printing technology, you would also like smooth the hole or like this disaster that I hope will never happen to anyone's home. And ideally, realistically, you would also need to have the CMU blocks or bricks to kind of patch this the hole. Because of course, just to bring the printer to print some small stuff, I wouldn't say it's like the wise decision. So repairing can be done the same as you would do for the brick wall or CMU wall. Because again, the material is pretty the same as the CMU blocks. And you can actually like put there some CMU blocks and use the same materials for the crack repairing for CMU, for example. So this is why we were trying to create something that would not require to change everything, right? So how we can still do something innovative, but still we can use all of the tools that are available today. So basically, it's not a big deal to repair the 3D print wall. Long story short. Yes?
So for more complex geometries, say you have someone requesting a dome roof, so like in this case, is it a mechanical limitation or is it a material limitation to 3D print I guess a dome roof?
I would say it's both. And this is where we actually can tell more about the material. So the 3D print material, again, it's not the same as the regular concrete because regular concrete cannot be extruded. And so the 3D print material has the fast setting time, it has higher viscosity, so it's really different material because it has to set pretty quickly, but not too fast, so it's not stuck in the hoses and the machine itself. So dome can be printed if you kind of tune the material, so the layer all the time kind of can maintain the next layer, I would say. So this is the question for material science, and it's something that we already tested in-house. And so then the mechanical as well. So I would say like a structural part of this too. But actually, I saw 3D print houses that were 3D printed as dome. So a lot of companies so far was pretty successful in this, so it's possible.
So would has there been consideration for a secondary print head to make like a supporting lattice structure for more complex surfaces?
No. I would say that the dome structure, it's really the question of the right material, right printing speed, and equipment as well. So having the second head on the printer, it's something that probably might be a good idea, but it's really hard to say unless you try this, right? So today we're trying to like how we can achieve this result, be very stable in this, and then we like add more complexity. So honestly, I don't know the right answer for the question. It's really like a forward-looking and pretty visionary question, but let's see.
In line with, because I saw like the concept, those nice renderings, those concept images for what our home on Mars would look like if it were 3D printed. So and I did see some complex geometry there. So I guess that's where my question was leading towards.
Okay.
So would it be would it be with the aid of the material mechanics and of course and/or perhaps a secondary print head to be able to achieve those kinds of effects?
So this, for example, is obviously the combination of different construction approaches. So with 3D printing, you create the shell, And all of the other stuff, it's actually different materials, it's installed differently. So for the more like a complex multi-layer construction is of course going to be there, not just the one printer with one hat. Yeah.
Thank you so much. Really cool. All right, so a couple of orders of business here. So the votes are tallied. All right, so the votes have been tallied. For the best technical print, the winner is number 7. Who printed number 7? Woo! Number 7. The most creative print was number 2. Woo! Right on. And epic fail was number 3, but that one is disqualified because it's me. So I'm going to donate it to Ricardo over here because he at least brought in his fail. So congratulations. So each of those people will get 5 points towards the 3D printer's ball at the end of our year, which is in October of next year. So there's some surprises coming on for that. I'll just give you a hint. It's October. Your 3D printers. What could that mean? So, actually, so what I will do is actually, Arthur, since you were on the last set of questions there. All right. You want to issue the new challenge?
Okay. So, like at the last 3D printing meetup, where Adam was so cordial in presenting a 3D printing challenge, we have a new challenge that is coincidentally not too far from what I do for a living, which is designing toys. It's a toy challenge. So with Christmas around the corner, you'll be tasked with to print your favorite toy. The challenge, should you choose to accept it, is to print your favorite toy. It can be a brand new creation or something you particularly love and cherish. It can be a toy from your childhood, or it could be a toy you've dreamed of having, and now 3D printing makes it possible. Bonus points if you use newfound technology to print out a classic toy, for anyone that's a fan of traditional wooden pull toys. Or if anyone still has one of those original Lego lacquered wooden toys, please contact me. I would love to interview you because those are sought after collectibles. I kid you not. And the categories will be best technical print, most creative, and most fun. And the next meetup is going to be on January 20th. At 6 p.m. and there will be the added bonus of a gift swap. So not only are you printing things to show, you are also gifting them.
Thank you.
Thank you so much.
So at this point, print fails might not be acceptable, given a few exceptions. Maybe one person might request.
I don't know. Does anyone like failed prints? No. Okay. Didn't think so. Fantastic. Thanks. Do you want to what's that? Do you want to help us pick? So we got the raffles here.
Ooh, raffles. I hope I don't pull my name because that would be awkward.
Just stick my box.
Nathan Lee.
Nathan Lee. Here we go. Print us something great.
Okay. Another one. I have a good feeling about this one. Christine. Really?
Good incentive
And we got one more.
One more. Dig deep. Dig
One
deep.
more. Not manipulating this in the slightest. I promise you. I'm trying. I'm really trying.
trying to manipulate it? Or?
Well, no, this was just by luck. It was just by luck. It's me.
It's you. Right on. Do you want to take another one?
Fine.
Come on.
Okay. All right. Nick.
Thank you. Yeah, thanks for being here. You owe me a 3D printing robot. There's plenty at the back. Great. Well, thanks. So one of the things that I want to also create in the space, and part of why we had the fail category, is to talk about our challenges. So, we're all out here, we're trying things, we're pushing the envelope. Maybe we're pushing our envelope, but somebody else has the skills or the know-how to help. So for this last little bit here, I'm just gonna open up the floor, and maybe somebody out there has a challenge or something that's vexing them, either material selection, printer setting, something that's going on that you want to just sort of throw out there for the group to think about and discuss. So who's got a problem that they want to share? 3D printing problem, by the way. Really? Am I the only one? Arthur?
Perhaps this is a problem that someone might have come across more than once. And actually, this would be a perfect example. This print technically is actually full of zits, even though it's textured to make it look like potential. It's actually not. It's supposed to be a smooth surface, but it's looking like it was made out of plaster. So I guess the question to everybody is: have you ever come across zits in your 3D prints? You've escaped zits from your adolescence, and now it's haunting you to make your 3D prints. How do we smooth it out? Unfortunately, proactive won't be the answer this time.
What are your thoughts?
I had an issue like that. It was found out it was a setting slicer. The file had too many triangles, and the printer was trying to make 1,000 movements in a millimeter, zits. So basically, lower the amount of, smooth out the amount of movements in a small space. That's all someone would say.
So in that case, to get rid of zits from your